Now, during this lecture, a lot of questions will come. We will accept all those questions. Before we take questions, as we do what we understand, our full attention, full focus would be on concept, on understanding concept. Same this during this lecture we will do. Before we jump on question, first of all we will complete our concepts. We will complete our concepts. Okay, this is your process. As you can see, I wrote something which is equation of motion. There are three equations of motion, and so there are some questions based on these three equations of motion. Remember, chapter name is motion in a straight line. Motion in a straight line. I'm not starting this lecture from starting. No. Topic is what? Equation of motion. First step is what? First is going to be V is equal to U plus AT. V is equal to U plus AT. This is your first equation of motion. First equation of motion. Okay, and next will be your. So this first equation will be used to calculate V velocity, final velocity, or you can use this first equation to calculate initial velocity as well. Next, second equation of motion is S is equal to ut plus half as square. As square, not as square but at square. At square. Okay, second. And third is v square. Third is v square. Third is v square is equal to u square plus 2as. 2as. These are three equations. It's not difficult to remember. V is equal to u plus at. Third, v square is equal to u square plus 2as. A lot of time this equation will be observed. A lot of time. In short, I can say this equation is used when object is coming to rest. Yeah. When object is coming to rest, then this equation will be very useful to apply in our case. This equation, second equation, will be used to calculate displacement. It can be vertical displacement, it can be horizontal displacement. S is equal to ut. S is equal to ut plus half a square, half a t square. S is equal to ut plus half at square. Ut plus half at square. This second equation of motion will be used to calculate the displacement. However, we can get T, U, A, S. All these things we can get from this equation. Okay. So S is equal to second equation of motion is S is equal to ut plus half at square. V is equal to u plus at, and v square is equal to u square plus 2s. Can you write again? V square is equal to u square plus 2as. V is equal to u plus at, and s is equal to ut plus half AT square. Half AT square. This is the first, and this is second, and this is the third equation. Okay. Apart from this three equation, there are more. Ascent, ascent, ascent. In this, we have some variables. First is u, v, a, t, s. So v is u is your initial velocity. Initial velocity. V is your final velocity. Final velocity. T is your time period. And S is your acceleration. Okay. And that's it. S is your displacement. Displacement. S is your displacement. Okay. These are full name of not full name, full meaning of some variables that are present in this formulas, in these three equations of motion. I have written over here. Now for ascent means in 1 second, what is the displacement? Okay, in 1 second, ascent displacement. It is known as ascent displacement. Displacement in 1 second. For example, question is saying in fourth second, you will understand that 3 to 4, 3, 4. This between this second, what is the displacement? For this, we will use this formula, ascent. Okay, this was meaning of ascent. It is not a hard. Okay, u plus, it will be u plus 1 by 2, 2n minus 1 and 2a. Distance formula. So ascent is equal to u plus half into 2n minus 1 and 2a. This form, you don't need to remember this formula. As you will be doing a lot of equation based on this formula, you will understand automatically. There is no need of pressure. This was our fourth formula. It will be used to calculate the displacement in 1 second. Okay. Now next we have average velocity. Average velocity, average speed. It is nothing but total distance upon total time. You know, average velocity, which means initial velocity plus final initial displacement. I would say initial location plus final location. U plus V upon 2. This is your answer. Upon 2. From this formula you will get average velocity. From this formula you will get average speed. Let's take questions. Just have a look. Now we are going to take a question. Next question is next question is yeah. This is complete question. There is a particle, or you can say there is a person. This person can be you. There is a person which is a starting which is a starting motion from this reference point where x is a 0 from origin. This person, he is moving with a velocity of a 50 meter per second. Velocity of a with a 50 meter per second, and acceleration is a 10. Acceleration is a 10. So at t at 4 second, what is the location of a particle? Of course, x will be something else instead of 0. And what would be velocity at 4 second? At 4 second. So velocity will be u is a 0, u plus at. So a is a minus 10, t is a 4. So b came as a minus 40 meter per second. At 4 second, velocity of a person will be 40 meter per second. 40 meter per second. But what about location? Hold on. Zero is not a velocity. Zero is a location. Zero is a location. Zero is a location. And this 50 meter per second is an initial velocity. So an initial velocity is 50 meter per second. An initial. What would be final velocity? What would be final velocity? Final. So for final we have v plus u plus at. V is equal to u plus at. The final is not given. That is what we have to calculate. An initial velocity is given, which is 50. A is minus 10 and time is 4 seconds. 4 seconds. So velocity came out as a 10 meter per second. 10 meter per second. Add 4 seconds. So add 1 second. Initial velocity is 50. So tell me acceleration is 40. 40. So add 4 second. 10 multiple 40. 10 multiple 40. So 40. 50 minus 40. Velocity is going to be 10 at 4 seconds. Where acceleration is a positive. Okay, and negative in opposite direction. So velocity came 10 meter per second. Of course, this will decrease because acceleration is opposite in opposite direction. What is the displacement? Displacement from 0 to 4 seconds. From 0 to 4 seconds displacement. From 0 to 4 seconds. We now at 0 second, at 0 second velocity is initial velocity is 50 meter per second. At t is equal to 4 second, final velocity is 10 meter per second. We got initial velocity, we got final velocity. Acceleration is how much? Minus 10. Total time is how much? 4 seconds. Total. Let's apply a second equation of motion, which is S is equal to ut plus half at square. Initial velocity is 50. A is 4. 1 by 2. This is minus 10. Time is 4 raised to power 2. 2 5 is 200. Hold on. This is our plus 200 plus minus 50. Not minus 50. Only 5. Minus 5. 4 4 is 16. 200 minus 80. 120. This is your displacement. This is your displacement. Try to understand. What is the meaning of this coming answer? This coming answer. What is the meaning of this coming answer? 120. It is telling you from here and from here t is equal to 4 seconds. Here t was 0. When he came to here, then velocity was 10 meter per second, and question is asking this displacement. What is this displacement? So distance, or you can say this displacement is nothing but 120 meter. You can say 120 meter. 120 meter. In 4 seconds, he covered 120 kilometer distance, or you can say displacement. Now third, location. What is the x here? What is the x? X means location. Where is he present on x-axis? For this, we use third equation of motion. Which is v square plus u square plus 8. u square plus 80. No, 2as. S is nothing but location. So instead of x, we will replace this by x. So next question is find the where particle will come to at a rest. He wants to know what is that place where particle will come to rest. Means final velocity is going to be zero. Final velocity. This is not final velocity. Here velocity is a 10 meter per second. It will cover more distance to come at rest. Initial velocity is 50. Final is 0. U is given, A is also given. We will get X, which is location of that person. This is U is a 50 raised to power 2 plus 2 multiple A. It is nothing but minus 10. X, this is what we have to calculate. 0, 2500 minus 20x minus 2500 upon minus 20 is equal to x. 125. X came out as a 125. At this position, that person is present. Location you will find by using third equation of motion. Displacement will be calculated by using second equation of motion. Velocity, initial velocity, I would say final velocity will be calculated by using first equation of motion. Next question. Let's write next question. This is the next question. It is asking, he is asking first question, which is find the velocity at t is equal to 5 seconds. At t is equal to 5 seconds. Remember, this three equation of motion will be used when acceleration is a constant. I am not saying acceleration is a zero. No, acceleration will be constant. Hence, it is 5, then it will be 5. It is 10, then this acceleration will be 10. Okay. But acceleration is not constant, then we use something else. Right now we have this question. Let's accept what will be solution. A particle, there is a particle again. That particle start doing motion with an initial velocity which is 30 meter per second. Okay, initial velocity. So Vi is 30 meter per second. Vf will be with the 30 along x-axis. Horizontally it is a covering distance with the velocity 30 meter per second. Such that acceleration is going also horizontally, positively. So acceleration is a 10. Acceleration is a 10 meter per second raised to power 2. Raised to power 2. Okay, no problem. We have to calculate what is the velocity at a t is equal to 5 seconds. Final velocity. Final velocity. So what will be your final velocity? Can we use the first equation, this first equation of motion? Yes. Yes. A is given. T is also given. U is also given. So we have to calculate V, which is the final velocity. So V is equal to U plus T. V is not given. That is what we have to calculate. So V will be as it. U, which is a 30, plus A is a 30, 10. A is a 4, not 4 but 5. After simplifying this, answer will come out as 30 plus 50, 80 meter per second. Remember, this is your final velocity. This is your final velocity. Okay, so we got final velocity, initial velocity, A and T. Now let's take next question. Find the displacement. Find the displacement in 5 seconds. Time is from 0 to 5. In 5 seconds, how much distance, how much displacement he covered in 5 seconds from 0 to 5? For this, we should have initial, final velocity, which is we have. Okay. So for displacement, we use second equation of motion, which is S is equal to ut plus half at square. U is 30, t is 5, half multiple a is 10. Yes, a is 10. T is 5 raised to power 2. 2 5s are 10. 3 5s are 15. 150. 5 multiple 25. 25. 100, 200, 250, 225, 225 is your displacement. A person who started running, with initial velocity which was 30 meter per second, and he stopped at a place with a final velocity which was 80 meter per second. 80 meter per second. So between this time, this much time he took. So with this much time, how much distance he covered? So he covered 225 kilometer distance. Okay. Now next, after distance 500 meters. 500. It can be different question for you, but not it is not too much different. Look at this third question. Look at this third question. Try to understand. He is asking find velocity of a particle after traveling 500 meter, 500 meter, 500 meter distance. Distance. So S is a 500. Directly you can say S is a 500. So what is the velocity of that particle? So velocity will be v r square is equal to u r square plus 2as. We have to calculate this p. U is how much? 30. So square plus 2 multiple 10 multiple s. S is a 500. S is a 500. V r square. 3 3 is a 9. 900 plus 2 10 to the 20 and 5 to the 10. 10 to the 20 multiple 500. 900 5 to the 10. 10,000. Yes, 10,000. From this you will get your V. You will get your V. This is for you. Say after simplify this, what is coming your this V? This will be your velocity after where particle covered this 5 meter distance, 500 meter distance. Now next question, fourth, average velocity. From t is equal to 0 to t is equal to 5. Average velocity. As is some formula for this, average velocity is, this is symbol is used to, it is used for average. This is symbol, equality symbol. So what is u plus v upon 2. This can be written as, can you say u is a 30, okay, plus v is how much, 80 upon 2. You will get 120 upon 2, which is a 60 meter per second. 60 meter per second. This is average velocity. It is not exact velocity. We can't say that he was moving exact with this much velocity. No. We found the average. Means if he covered, let's say 500 meters, so we can say that yes, he will be moving, he will be driving a vehicle with this much velocity. But when it comes to average, we know that traffic comes in front of our vehicle, somebody comes In this situation we have to apply brake. So what about this situation? That's why we can't say that this was we were driving with exact this much velocity. No, we found a velocity which is average, which is average. Remember 33, 110, 110. So this will be your 55. This is the first option. Now next is displacement in fifth second, means from 4 to 5 in 1 second. What is the displacement? For this, as you know, we use S-synth formula. uh, U plus formula is U plus half, U plus half, U plus half into 2n minus 1 into a. So U is a 30 plus 1 upon 2, 2 multiple, n is a 5 minus 1, a is a 10. 30 plus 2 5s are 2 5s are 10, 45, 45. So this is going to be your 75 distance. This was covered between this second, within 1 second. This was covered in 5th second. That is how you will calculate 75. Now let's see average speed. Average speed, we know total distance upon time. Time is 5 seconds. But what about the distance? From this answer we cannot get exact distance. Exact distance. We know what is the time. But what about the distance? What about the distance? What about distance? So we will see it later in later part. Right now let's see average acceleration. Average acceleration, which is initial velocity minus final velocity minus initial velocity upon t. So your final velocity is 80 and initial is 30. Time is 5. This came as a 10 meter per second, which is given over here. Average acceleration is 10 meter per second. Now let's take next question. In the next question that I am going to write, our focus will be on on ascent. Ascent. Let's take next question. There is a particle again. Yeah, this is your complete. Look at over here. Your full attention, I would say, your full attention should be on this solving question because it is a little bit different from the previous question. A particle which start motion with the initial velocity vi is we have started solving this question. Vi is 20 meter per second. Having acceleration is 10 meter per second raised to power 2. Find the displacement of a particle in fifth second. In fifth second, what is S? What is S? S. We don't know final velocity. We don't know final velocity. You can get this final velocity from by using first equation of motion. So should we use first? Yes, you can use u plus at. U is 20 plus a is 10 multiple time is ignore it right now ignore it. Tell me, there is object like this. There is object. From here, this object started moving. with this much velocity. Let's say from here, from here. So t is 0 over here and k is 5 over here, over here. And he is moving how much with 20 meter per second, means vi, vi, vi. We don't know what is velocity at this, at 5 second, at fifth second, at 5 second. We don't know. Okay, don't care about this. He wants to know what is the displacement from t is equal to 4, from t is equal to 4, this displacement he wants to know, this displacement. So can you say that from here to till here this is our first displacement, and from here to till here this is our next displacement, next displacement. But this will be your x1, and complete from t to 5, this will be your x2, x2. When you will subtract this x1 by from x2, you will get this part, you will get this part, this part. So finally we have this s is equal to, not s, yes, if we use this x, displacement, we are finding displacement. So s from t to 4, t to 4, t to 4, t to 4. So s is ut plus half ATSY. U is initial velocity is given 20, multiple t is 4 second. Addition sign 1 by 2. A is 10, multiple t is again 4 raised to power 2. From this we will get the displacement from here to till here, which is x1. This is x1. 80 plus 2 5s are 10. 4 4s are 16. 65 is 80. It came out as a 160. So x1 is a 160. That's a meter. Now x2. What is x2? From t is equal to 0 to t is equal to 5. Okay, t is equal to 5 till the 5 second. Till the 5 second. Same formula we will use. x2, u is 20, multiple t is 5 plus 1 by 2, a is 10, multiple t is 5 raised to power 2. 2 5s are 10. Now it is 100. 5 multiple, then this will become 75. So finally we have 175. So x2 is this displacement from here to till here. This displacement we have, which is 175, and from here to till here, this is displacement of this line is 160 meter. Now we want only this part. So to get only this part, we will have to subtract this 160 from 175. We will get automatically this part. So let's say this is s. Okay, s. So s is equal to x2 minus x1. So finally x2 is 175 minus 160. S came out as a 15. 15 meter. I think so. This is 15 meter. One thing I did wrong. Two fives are 10. Five fives are, and 20, 5 twos are 10. 5 twos are 10. U is a V, 20. 5 twos are 10. 100 plus 5 multiple. It is not 125. 20, 100. So two fives are 10. 100 plus two fives are 10. Yes, so this part is how much? 50 meter. This part is 50 meter. This is your answer. That is how you will solve. Otherwise, you have another option, SN formula. U plus half 2n minus 1 a. U is a 20 plus 1 by 2, 1 by 2, 2 multiple, n is a 5 minus 1, a is a 10. 2 5s are 10, 20 plus 5 is a 10, 45. So 65. Answer is coming as a 65. So I think we did wrong over here. 65. This is a 200, 225. 225. 5 5s are 25. Then again 125. Yes, this will be 125. 225. Then this will be 65. This is our 225. We found this ascent this much displacement by using two method. This was first method and this is a second method. Whatever option do you want to select, you can select. Answer will be same. Answer will be same. If your process of solving equation is correct, then answer of course will be same. Whether you are using this option, this method, or this method, this formula. This is your choice. This is your choice. Now next question. Yeah, this is your next question. Solve it after understanding, complete, after getting complete, after getting complete clarity. Try to solve this kind of equation. The distance traveled by a particle. The distance traveled by particle starting from rest and moving with an acceleration this much, and the third is and the third is acceleration is 4 by 3, 4 by 3, 4 by 3. Have a look. Can you say this particle started rest from rest, means initial velocity will be zero, initial velocity will be zero because it is started from rest. Question is not saying that particle uh, who is at this point is with this much velocity. No, like that question is not saying. Question is saying particle just started moving from rest. So of course initial velocity is going to be zero. It is going to be zero. Okay. So initial velocity is going to be zero. So it is asking in third. In third, what is our displacement? Displacement in 1 second. Okay, in 1 second. So when it comes to nth, snth, of course we use formula snth is equal to u plus half 2n minus 1 a. This is snth formula. We use it to calculate the displacement in 1 second. In 1 second, with the acceleration, given acceleration, with the given acceleration, snth is equal to u is 0, 1 by 2 as it, 2 multiple 3 minus 1, and a is 4 by 3. A is 4 by 3. 0 will be as it, 1 by 2 multiple 3 to the 6 minus 1. It will become 5 multiple 4 by 3. 2 to the 4. 0 plus means 5 to the 10 upon 3. This is your displacement. If you simplify it further, you will get 3.33, which is a non-terminating number. Snth. So total displacement is non-terminating. It is going to be equal to 4, but not add. This will not be 4. This will not be 4. 10 by 3 is our displacement in 1 second, in third second. In third second. After this we will see. We will see some questions based on some from. During this lecture, we were using formula of motion, three equation of motion, which was v is equal to u plus at. We used s is equal to ut plus at square, half at square. We used v square is equal to u square plus 2s. We used snth is equal to u plus 1 by half 2n minus 1 and 2a. All this formula was used. Then we solve this formula, average velocity, which was initial velocity, initial location of particle plus final location of particle by 2. Now initial velocity plus final velocity upon 2. We have seen all this formula, uses of all this formula with the questions. In the next lecture, we will see current, how to calculate current, or you can say instantaneous velocity, instantaneous acceleration, current acceleration, how to calculate. Formula is V is equal to for current acceleration, for current velocity, V is equal to dx upon dt, where x is the location of a particle, t is the time. For acceleration, we have dv upon dt, where v is the velocity of a particle, t is the time. We will do some question in which question will be providing the location of a particle, which will be like this: x is equal to 4i plus 2z cap, yes, like this. This is location in vector language, If you do this, if you do double differentiation this v, then you will come to the acceleration. Double means v is equal to d square x upon dt square. This is equal to acceleration. Okay. You will see one thing more, which will be a is equal to p into dv upon dx. This will be used when t is not given in the question. Then you can use. And question might be asking what is the location of a particle, where velocity of that location is given. Your work is to calculate location of that particle. Then you will be able to use this formula, where t will not be given by the question. Okay. This formula you can use when question is providing velocity of a particle. Velocity is particle. I will tell you in the part of this lecture. In that lecture, we will see uses of all these formulas. V is equal to dx upon dt, a is equal to dv upon dt. A is also equal to b into dv upon dx.